look at evaluating logs on our calculator. So let's start with the function, just the log of x, the common log of x. If x equals 10, now we can do this one, okay, without our calculator because the base is understood to be 10, so 10 to what power is 10, okay? This answer is 1, f of 10 equals 1. But let me show you where the log button, I think y'all know because you graphed it. So the log button on your calculator is beside the 7. So then you type in the 10, close the parentheses, and it gives you 1. Okay. The next one, though, the log of 1/3. Okay. 10 to what power is 1/3? Now, just because we can't figure it out in our mind does not mean it doesn't exist. It's just not an even rational power of 10. So we have to rely upon our calculator. We just type in the log of 1/3, and it gives us an answer of negative is approximately negative 0.477. Okay, so when we raise 10 to the negative 0.477 power, we get 1/3. It kind of makes sense if you kind of rationalize through it. Okay, it's a fraction, so the negative part of the exponent makes sense. And 0.477 is really close to 1/2, right? And 1/2 is the square root. The square root of 9 is 3. 9 is pretty close to 10, so it kind of makes sense that this is the answer. Okay, 2.5. Okay, again, just simply typing it into our calculator. Thank you, Phyllis. Okay, that one is approximately 0.398. Okay, approximately 3.98. And then -2. What happens when we type in -2? We get an error. It says non-real answer. Okay, f of -2 is undefined because we cannot take the log of a negative number. Why not? Okay, we cannot raise 10 to a power and get -2. Because raising 10 to a power means we multiply 10 by itself a certain number of times. There's no way to take a positive number, multiplying it by itself any number of times, and wind up with a negative number. Okay, that is why you cannot take the log of any negative number. Okay, now we're getting ready to get to solving here in a minute. That's not to say that we can't get a negative answer. Okay, we can get a negative answer, but you cannot just take the log of a negative number by itself. All right, let's look at the natural log. It is also a button on our calculator. Okay, it's right beside the 4. It's right below the log. Okay, so natural log of 2. Let's just type these in real quick. Natural log of 2, natural log of 0.3. Do I need to type in the third one? No, because it's the natural log, the same rules apply. It's the same idea. We cannot raise e. E is, what did I tell you yesterday, day before yesterday? It's approximately 2.7 something. Okay. You cannot take the natural log. You can't raise e to a power and get a negative number as well. Okay, so f of -1 here is undefined. UND, undefined. Okay, and the last one I just threw in there to show you that you can do it of strange numbers, complex. Well, this isn't complex. This is irrational. Okay, you can take the log of an irrational number. That's not a problem. The only problem is the log of a negative number. Can't do it. But somehow, some way, we can raise e to the 0.8881 power and end up with 1 plus the square root of 2. Good to know, right? All right. So let's look at some properties of logarithms that we need to understand, and we need to try and simplify these expressions and get rid of the logarithm. So the first one, log base 4 of 1 is 0. I'm going to keep throwing that in there so that it's just automatic gut reaction. If we're taking the log of 1, I know it's 0. Every single time, it's 0. All right. B, let's look at that one for a second. 5 times the log base square root of 7 of the square root of 7. Well, just look at the logarithm for a second. Now let's think about that. What would that be equal to? 1. Because it's saying, well, if I raise the square root of 7 to some power, I'm going to end up with the square root of 7. Well, to get itself, you're raising it to the first power. So we've got 5 times 1. So this expression, even though it looks all big and bad, it's really just 5. So when your base and what's inside your logarithm are the same thing, the answer is just 1. Okay, similar thing going on here with C. Okay, now I couldn't write it, I couldn't do an exponent and the subscript, so really this is what we're looking at here. It's a little bit better to look at it this way. So let's think about this one for a second. 6 and 20 don't have a nice whole number exponential relationship, okay? I can't tell you 6 to what power is 20. I know that it's somewhere between 1 and 2, because 6 to the first is 6, 6 squared is 36, 20 is somewhere between 6 and 36. But without using my calculator, I can't tell you exactly what that number is, okay? But let's think about this. 6 to some power is 20 is the answer of what's in the exponent. And then I'm raising 6 to that power. So what's the answer? Think about that for a second. 6 to some power is 20. Okay, so whatever that answer is. And then I'm raising 6 to that power. 20. Okay, 6 to some power is 20. And then I'm raising 6 to that power. So the answer is 20. It's kind of like if the base of your log and the base right here are the same, it's kind of like they cancel each other out. Okay, so I was trying to do it without the calculator, but let's look at this. Some of your calculators, some of you that have your own, if you have one of the newer ones, it will let you change the base of the logarithm. But these calculators won't. But do y'all remember how to evaluate that on your calculator? Log base 6 of 20? Y'all remember how to do that? Change your base. Okay, the log of the, I call it the big number, okay, not the subscript. It's not necessarily the bigger number, but it's just physically bigger. Okay, the log of 20, make sure you close parentheses, divided by the log of 6. So like I was saying, I knew it was somewhere between 1 and 2. I didn't know exactly what it was, but it was somewhere between 1 and 2. So there's the answer to the exponent. And then I'm raising 6 to that power. Whoops, wrong button. 6 to that power. And I get 20. Okay. So the answer is 20. Okay. How about the next one? Natural log of 1 over e. What do y'all think that one is? Negative 1. What if I write it like this? Okay. 1 over e is the same as e to the negative 1. Okay, it's kind of like the natural log and the e cancel each other out. So that is negative 1. E, example e, okay, e to the natural log of 5. E and the natural log are inverses, so they cancel each other. So that is just 5. This is just like example C. Okay, it's just using the natural log of e instead of the log and the base. All right. How about F? I've got the natural log of 1 divided by 3. What's that answer? What's the natural log of 1? 0. What's 0 divided by 3? 0. Okay. All right. And G, 2 times the natural log of E. What do y'all think? 2. The natural log of E is 1. Okay, because E to the first power is 1. And so then 2 times 1 is 2. Okay. So this was all about just using simple properties. But I really wanted to point out there in C, D, and E kind of how those cancel out. Okay, kind of how those cancel out there. Alrighty. All right.